Right. So, welcome to Health, Wealth, and Web3. There's This is kind of a follow up, I guess, to some of the things I discussed yesterday's episode. So, free radicals and antioxidants, and why are they important? Why do we need to care about them? And also the question, what does a 23-year-old premature baby have in common with a 65-year-old person who has suffered from a spinal cord injury from falling and breaking their hip? It's a surprising answer, and that yeah, it's so let's just get to it. So with a 23-week-old premature baby, um, they are basically their body systems are not very well developed. They're not, so they have to have assistance in certain things like they have to have extra oxygen given to them, and the oxygen that they have to be given is higher purity in oxygen, because right now it's only we're breathing approximately I think it's like 21-23% oxygen, as opposed to there's 71% nitrogen in the air right now. With a premature baby, they have to have uh, more oxygen delivered to them, essentially. But what we see with these premature babies who are getting this higher purity of oxygen, um, this oxygen is causing what's called reactive oxidative, ROS. I can't remember what the S stands for right at this moment, but reactive oxidative species or something. But that it's so essentially this oxygen, what it's doing because it's so pure, it's imbalanced in a way, and so it's going into these babies' lung cell tissues, and specifically this oxygen is going into the mitochondria of the lung cell tissues. And what these reactive oxidative species, there we go, uh, what these free radicals from this oxygen that these babies need this oxygen in order to survive, but this oxygen that's being delivered to them is actually um, it's wreaking absolute destruction in the lung tissue, mitochondria specifically. And so what we're seeing later on in life in these premature babies who have to receive this additional oxygen, and they receive damage from these reactive oxygen species. Uh, the Basically the long-term health of their lung tissue and their lungs overall is severely impaired, um, to the point where development can uh, development of their lungs is greatly inhibited, and just their quality of life, their length of life, things like that is unfortunately they're going to suffer pretty significantly. Um, so how does that relate to a spinal cord injury patient? So what we see in spinal cord injury patients is that normally a spinal cord injury patient is there's some type of damage, there's some type of trauma that the body sustains, and that leads to the damage to the spinal cord, whether it be broken vertebrae, whether it be the damage to the intervertebral discs, things in between the vertebrae. The spine can twist, it can get stretched out, and there's a lot of unfortunate things can happen to the spine. But once that trauma is sustained to the nervous tissue specifically, in the spinal cord, and some of these spinal nerves that are coming off of the spinal cord. Um, so what we see with this trauma, this damage that happens to cells, there's basically ruptured cells, and there's just a lot of debris. There's a lot of garbage that's kind of floating around freely. And what we see in clinical studies that there's an increased amount of free radicals, just this debris that's floating around, and the mitochondria specifically of the neurons of the nerve tissue, the mitochondria get overloaded. They can't refresh and recharge the energetic circuitry quick enough, and they get so overloaded that basically the neurons in spinal cord injury patients are non-functional, or they can't function. They're broken. The back is broken, or there's damage to nerves, but what happens on a base level is the mitochondria are broken, and that's because of free radicals that have overwhelmed the mitochondria. So this is on the nerves and the neurons and nervous systems specifically. So what we see with the 23-week-old premature infant who has to receive oxygen, and the 65-year-old patient who fell and broke their back, we see that basically it's the mitochondria that are affected, and it's the free radical damage that's happening to these mitochondria that is leading to long-term health impairments. So in certain clinical studies, they have introduced certain antioxidants to spinal cord injury patients, and there's quite specific. So it has to be within 48 to 72 hours of that initial trauma happening. But if a couple specific antioxidants can be introduced to a spinal cord injury patient system within that 48 to 72 hour window, there, we see long-term, short, medium, and long-term recovery improve by up to 85%. So just, that's enormous when it comes to spinal cord injuries. Just functionality, sensation. There's a lot of things that, that's 85%, up to 85% improvement in recovery, in less damage that's actually happening to the neurons, the nerves, and those mitochondria specifically. So for the premature babies, it's on the lung cell tissue specifically. For spinal cord injury patients, it's on that nerve tissue specifically. So it's on different cells, but the cellular structure that is being affected is the same, and is being affected in a very similar way. There's free radicals that are overwhelming the mitochondria and the mitochondrial function. Because the maternal mitochondria are, that's the determining factor when it comes to genes. That's paternal has certain effects, but like the mitochondrial, the maternal DNA is only where that mitochondrial genetic information comes from. And when the mitochondria are being affected by free radicals, so specifically, it's literally the genetic structure of those mitochondria are being affected and changed in a way that just leads to suboptimal outcomes. So why and how does this relate to, kind of what I was talking about yesterday, these ionized atoms, or these ionized electrons that are bombarding our systems? It works in similar ways. So when it comes to free radicals, there's different types of free radicals. There's the broken cells and just the debris and junk and garbage from cells that die from oxygen being too pure. It can cause free radicals, and they're all going to kind of affect different structures, different cells, different organ systems in different ways. But it's at that base level, when it comes to just the world that we live in, the world we interact in, free radicals are at that base level, impairing our mitochondrial health and our mitochondrial genetic health and resilience. So why do we need antioxidants? I mentioned pycnogenol yesterday. So what pycnogenol does is pycnogenol helps. We have natural. It's called one of these pathways called the glutamate pathway, and it's the body's natural ability to produce antioxidants and produce certain benefactor cofactors to help with antioxidant promotion and just help prevent damage from free radicals. So pycnogenol is one thing that really specifically and really it's a very strong antioxidant. So it helps your cells ability to be resilient against these free radicals. It's quite enormous. It's clinically significant. So why do we need to care about free radicals? We need to care about antioxidants, and why do we need to increase our consumption of antioxidants in our modern day and age? So I mentioned in yesterday's episode also, just there's kind of this base level inflammation that we're seeing across all population groups. Kind of doesn't matter the population group, doesn't matter the what type of health impairment that you may have, that we're just seeing that kind of this base level inflammation, even from stress. Stress alone causes enormous amounts of inflammation in the body in different ways. So this inflammation, what this is doing at a base cellular level, this inflammation and all these systems being overloaded and having to deal with this extra stuff that it can't quite deal with at that cellular level, that's our mitochondria that are not able to keep up with the rate of renewal that they optimally need. So by taking free radicals, or by taking antioxidants, it's going to boost our body's ability to fight free radicals in many different ways. And I mentioned with when you eat vegetables, fruits and vegetables, you should be eating every color of the rainbow. Those colors specifically, those are almost always, we find that those colors, those pigments in the plants that we consume, those pigments are quite typically antioxidants, quite strong antioxidants and quite beneficial antioxidants. In grape skins, there's resveratrol. In green tea, there's theobromine, ECGC, and I'm not sure if theanine is an antioxidant. It may be, but ECGC is the really kind of the main antioxidant in green tea. There's tomato skins. There's the tomato skins that had, I can't remember the starts with an L. The antioxidant in tomatoes and tomato skins, like, really specifically helps with men's health and like those testosterone systems and hormonal health. So getting the different colors of the rainbows when you're eating natural fruits and vegetables, is absolutely important. Frozen blueberries actually have enormously stronger antioxidant levels than fresh blueberries. That there's theories as to why kind of that happens. Basically these antioxidants, as blueberries freeze, they, in order to stay resilient, in order to stay beneficial and good for people, and to be able to proliferate, these antioxidants, as they freeze, up to 4,000 times increase in the antioxidant level that we see. And so that just means that blueberry, as it's frozen, it becomes 4,000 times more able to fight off cold and to fight off all these external environments and to stay, a healthy, good blueberry. So that's kind of what, for antioxidants for plants, they literally help the plants stay stronger, stay more resilient, and just kind of continue their proliferation and evolution. So things like pycnogenol, that like alpha brain, and a lot of nootropics, go-to cola. There's go-to cola, there's ginkgo, kind of a lot of these nootropics as well. Nootropics and antioxidants, they typically go pretty hand in hand. So yeah, consuming, why are free radicals? Why should you care about free radicals? Why should you care about antioxidants? And why does everyone need to be increasing their consumption of antioxidants? Well, in order to maintain your health long term, if you want to optimize and maximize our short, medium, and long-term health outcomes across the board, doesn't matter, disabled, not disabled, health problems, no health problems, like to maximize and optimize your health, and just optimize your potential, maintaining that cellular genetic health is we're coming to find out, with longevity being much more of a focus, like maintaining cellular health is kind of one of the main foundations that we should be establishing for ourselves. And incorporating and including antioxidants into your daily regimen, whatever it may be, that's just, everyone needs to do it, definitely. So just wanted to follow up with that. Thanks for tuning in. Thanks for watching. Good day, good night, good evening, all that. Catch you later.